So here's the question I know has been keeping all of you guys up at night. You've been so curious, just dying to know what you are going to do to solve for these different angles and these different sides when the triangles are not right triangles. Don't worry, there is a way. I will show that to you today. There's actually two different ways you can use depending on what sides you have and what sides or angles you need. The first way is called the law of sines. So for the law of sines, what you need is you need angles. So let's just label this triangle ABC, and then we're going to reference the sides opposite those angles. So since this one here is angle B, this side here opposite from that will be little b. Since this angle is C, the side opposite that one will be a lowercase c, and angle A will have side lowercase a opposite from that. So that will be important. The law of sines is a ratio where you have the sine of an angle is to the side opposite it as the sine of another angle is to the side opposite that one, as the sine of the last angle is to the opposite side. So to summarize, you put the sine of the angle over, if you want to like draw a fraction bar or something, the opposite side. And you won't have to do this with three of them, you'll only have to do two at a time, but I thought I'd go ahead and just draw that out with all of this for you. So looking at this picture here, this example, here's an angle, there is the side opposite from it, and here is another angle and the side opposite that. So because I have that information to start with, I can use the law of sines and I can set up a proportion, and then I could just solve it for x. So I would set this up as the sine of 60 over x equals the sine of 78 over 8. And this will actually work for any type of triangle. I've had students that really like this method, and they use this for right triangles also. You can do this sometimes with even right triangles. You may want to just keep doing sine, cosine, tangent, and that would be like my preferred method too, but this can work. So I need to grab a calculator. So I'm going to type in the sine of 60. So the sine of 60, and then I need to multiply that by 8. That's going to give me this number here. Well, then what I'm going to do is I'm going to have that equal to the sine of 78 times x. So I'm going to end up dividing by the sine of 78. So I'm just going to do that on my calculator, divided by the sine of 78. And I would just type all of this in at once. If you need to write these down as two separate numbers, that's totally fine. But the final answer for this, when we round it to the tens place, is about 7.1. So again, here's what I typed in. I typed in the sine of 60. And depending on how you're typing this into your calculator, you may have to put that in parentheses or maybe just close that parenthesis, depending on how your calculator gets it set up, will equal the sine of 78 times x. So then you end up dividing by the sine of 78, which is what I did. So the final answer for this one, just check it on your own calculator, make sure you know how to type it in, should be about 7.1 after we round it. For this next one, let's see, for this next one, again, I'm looking at the sides and the angles that are opposite from each other. So for this one here, I have a little bit of a problem because 54 is opposite from 8, but I don't have the angle that's opposite from this side. It's not too big of a problem though, because I can always find this angle when I have those two. So I would add those two up, and when I add those up I get 91, and I'm going to take that away from 180. So angle R is 89 degrees. Now I can use the law of sines, where I have the sine of 89 is to x as the sine of 54 is to 8. When I cross multiply here, I'm going to multiply 8 times the sine of 89. That's going to equal x times the sine of 54. And then to solve for x, I'm going to divide by the sine of 54. I'm going to do that to each side. And again, I would either just like write this down, or maybe once you got this, you can just know what to do on your calculator. Either way is fine with me. I'm typing in 8 times the sine of 89, close the parenthesis, and then divided by the sine of 54. And this would be my answer. I would say that that is about 9.9 after I round it. So the answer to this one is about 9.9, and all of these we can just round to the tenths place. Just a couple more examples like this. I'll go through these pretty quick too. Make sure that you look at your side and what that angle is that's opposite from it. We have the side here, the angle here. Since I don't know that, I gotta find that first. I'm going to add those up to get 94 and just take that away from 180 because all of those angles have to equal 180 degrees. This is going to be 86. So when I set this one up, the sine of 86 over 14 is going to equal the sine of 31 over x. 14 times the sine of 31. And then that's going to equal the sine of 86 times x. I'm going to divide by the sine of 86 and grab my handy dandy calculator. You guys really should be doing this too as we move along. Make sure you know how to type this. It's 14 times the sine of 31. And then I have to divide that by the sine of 86, and this would be about 7.2. So I'm going to write that the answer to this one's about 7.2. Move this over here again. And lastly for this one, I have side, angle opposite from it. So the sine of 125 over x is going to equal this side, and the angle opposite that one, I don't know. Add those up, 149. Take that away from 180. So this angle here is, let's see, 31 degrees. The sine of 31 over 6.8. I'm going to just go ahead and cross multiply this on the calculator. You can try it on your own. If you need to pause it quick, go ahead and type this in. I'm multiplying 6.8 times the sine of 125 and then dividing that number by the sine of 31. So the answer for this one is about 10.8. I write that down. That, ladies and gentlemen, is the law of sines. Most people prefer this one. I'll show you the next one in just a second. So the second way the law of cosines works when the law of sines doesn't. So the law of cosines, if I go ahead and label this, let's put that this is triangle, let's call it ABC. So we have lowercase a, lowercase b, and lowercase c. And this is just to give you a reference for where these angles are and sides. For this one here, it's really important that you know what the lowercase and uppercase letters are. So this would say that a squared equals b squared plus c squared minus 2 times b times c times the cosine of a. And I want you to write that out, but then I want you to write this next to it. I want you to write that this is a side. These are both sides. These are both sides. And this is an angle. Lowercase letters, uppercase letters, standing for different things. And then I also want you to write down that because these are the same letter, that's not a coincidence. This is the side and angle that are opposite. I promise once you do this a few times, it is not maybe as confusing as it maybe looks to you right now. Okay, so let's do a couple examples of the law of cosines, and just a heads up, these first couple are a little more work than the last one here, just so you know, so you're prepared. What you want to make sure that you have is you have the side that is opposite from the angle. So in this case, from this angle, the side that's opposite from it is 1.9. What I'm going to do when I set this up is I'm just simply going to put that side in place of A, and then B and C are sides, and those could be either order. So I'll say that this is A, B, and C just for something to keep track of. And then this one here would be like where angle A is. At 1.9 squared equals, B squared is 1.3 squared plus 2.2 squared, and then minus 2 times each of those. So 1.3 and 2.1, and then times the cosine of the angle, and that's what I'm missing here. So that's what I'm trying to find. I'm going to grab a calculator. We have 3.61 equals 1.3 squared, and that is 1.69. We have 2.1 squared, and that number is 4.41. And then all of this stuff here is being multiplied together, and it's really important, first of all, that you recognize that. So I'm going to multiply all of those things, but then it's also really important that you recognize that you can't add all of these up because they're not all like terms. What you can do is you can add these two up. So 1.69 plus 4.41 is 6.1 minus 5.46 times the cosine of x is going to equal 3.61. What I'm going to do now is I'm going to go through and just use algebra to solve for x. I have something being added here and something being multiplied, so I'm going to have to subtract that 6.1. I'm going to have to subtract that 6.1 from 3.61, and that is negative 2.49. That equals negative 5.46 times the cosine of x. My next step is then to divide. So I'm going to divide this number here by negative 5.46, and I get a pretty nasty decimal for that. 0.4560 equals the cosine of x, but I'm going to just leave that on my calculator because to solve for the angle, I need to take the inverse of cosine. So I'm just going to push second cosine of the previous answer. When you push second, it's the negative sign if you have one of mine, and that is about 63.9. And I think the directions for a lot of these from the book are going to say round to the nearest degree. So you could just say that that's about 63 degrees. And that would be your final answer for that one. I'm going to do another example just like this, and then I said the next one, the basketball one's not going to be quite this much to write out. For this next example, here's the angle and here's the side opposite from it. So when I write out my equation, you just need to make sure that you have that side and that angle kind of at opposite ends. The other stuff doesn't really matter the order that you write it. So it's one side squared plus the other side squared minus 2 times each of those multiplied together, and then times the cosine of the angle. So 3 squared is 9. You could actually, instead of finding out what these two are separate, just do all of this part on your calculator. So I could type in 4.5 squared plus 6.1 squared, and that number here for those two parts is 57.46. All of this stuff is together, so I need to multiply what? 2 times 4.5 times 6.1. That is 54.9 times the cosine of x. What I'm doing now then is solving this for x. So my first step is going to be to subtract that 57.46. So 9 minus 57.46. This number is negative 48.46, and that's going to equal negative 54.9 times the cosine of x. I need to divide by 54.9. I get 0.8827 equals the cosine of x, and then whenever you're finding the angle, you do the inverse operation. So this is going to be the inverse cosine, and I'm going to do inverse cosine of the previous answer. The answer to this is about 28 degrees after it's rounded. And here it gives you this diagram. Drew and Hunter are playing basketball. Drew passes the ball to Hunter when he's 20 feet or 26 feet from the goal. So this angle here, this would be 26 feet and 24 feet from Hunter. If the angle from the goal is 34 degrees, what we want to find is how far away is Hunter from the goal. So we want to find this distance here. Again, this one you can't use law of sines, you have to use law of cosines. But here they give you the angle and you're trying to find the side that's opposite from it. So when you set this one up, you're going to write x squared equals the two sides that are adjacent to that angle. Would be 24 squared plus 26 squared minus 2 times 24 times 26 times the cosine of the angle. And you'll like these a lot better because here's your variable. You can really just type all of that into your calculator in one shot and then just finish solving for x when you're done. It's a lot less things that you have to write down. Make sure that you try this on your own calculator just to make sure that you get it right. I'm going to type in 24 squared plus 26 squared minus 2 times 24 times 26 times the cosine of 34, and I get this number here. So this is not the final answer. We got to remember that this is what x squared is. To solve for x, you're just going to have to take the square root. So I would do the square root of the previous answer. I wouldn't even bother probably to write that down. The answer to this one is 14.7, and that would be in feet. So about 14.7 feet, or because it's a story problem, if you wanted to round this and say about 15 feet, As long as you had that work supporting that, that's what I'm most concerned about. And then for the last one, they tell us that the side B, so I know that that's the side because there's a lowercase b, is 10.2, C is 9.3, and angle A is 26 degrees. Whenever it's set up like this and you have one angle and you have the side on either side, you have to start this one out with law of cosines because this one is opposite from that angle. So I might start out saying that a squared equals, this would be 10.2 squared plus 9.3 squared minus 2 times each of those times the cosine of 26. So because this is the side, I don't mind doing this so much. I'm just going to grab my calculator and type all this in. You guys could be doing the same thing right now. Just be really careful. Sometimes I even make a mistake as I type this in. We want to make sure that you get like every little decimal, everything right. Otherwise your calculator might say that there's an error. So this is about 20. That's not the final answer though. A squared is about 20. And because this is not a final answer, you never want to round this off too soon. I'm going to take the square root of that, and to help ensure that, I'll just use all of those digits there on the calculator. So A is about 4.5, and it says that we can round those sides to the nearest tenth. And then to find angle C, we look to the side that's opposite from that. So I can set this one up with a law of sines. The sine of C is to 9.3 as the sine of 26. And this one's kind of tricky because if you're going to use this, you're using a rounded answer. So I would go back and like type in 4 after the decimal place so you have a more accurate representation of what that's supposed to be. So when I set this one up, I can cross multiply. So I'm going to type in 9.3 times the sine of 26. I'm going to end up dividing by 4.4733. And this number is what the sine of C is. And then to solve for that, I have to do the inverse sine of that previous answer. So this angle, and it says they want me to round to the nearest degree, this angle is about 66 degrees. And they're being pretty lenient in the book with having us round like that. I probably would have rather be more accurate, but that's okay. The book is going to say 66 degrees. For this angle here, you can do the law of sines again. You could set this one up. The sine of B over 10.2 is going to equal the sine of A, which is 26, over, and I'm going to continue to use that more exact number, 4.4733. So cross multiply 10.2 times the sine of 26, divide that by 4.4733. I don't know if you can see that. You get this 0.99 number. Again, make sure you do the inverse sine of that. So this angle here is about 88 degrees. I technically wouldn't have had to do this last one, but I just like it kind of as a double check. If you add up all of those angles, the 88, the 66, and the 26, all of those angles should add up to 180. It's just a good double check to make sure you did it right. So we'll practice this in class. I expect some questions, and I am looking forward to helping you guys.